Hello there, and welcome to the Dreamy Science Channel. I'm so glad you found your way here tonight. Maybe you've had a long day filled with rushing and noise, or perhaps you simply enjoy drifting off to the gentle rhythm of quiet discoveries about our beautiful planet. Either way, you've come to the right place. There's nothing you need to do now but settle in. Let your breathing slow and allow your mind to wander through the most soothing secrets of Earth. Tonight, we're staying close to home, not venturing into distant galaxies or cosmic mysteries, but exploring the gentle wonders of the world beneath your feet and around you. From the quiet conversations happening in ancient forests to the soft glow of creatures in the deepest oceans, Earth is full of peaceful marvels that will surprise you, comfort you, and perhaps linger in your dreams like whispered lullabies. If these calm explorations bring you peace or spark a gentle curiosity, consider liking and subscribing. It helps others find their way to this quiet corner of the internet, one restful soul at a time. The Earth hums a quiet song that only elephants can hear. Deep beneath the surface of our planet, seismic waves travel through rock and soil, creating vibrations so low that human ears cannot detect them. These infrasonic waves, often called the Earth's hum, resonate at frequencies below 20 hertz. Elephants, with their remarkable ability to sense these deep vibrations through their feet and trunks, can feel earthquakes, storms, and even other elephant herds from hundreds of miles away. They press their trunks to the ground and spread their ears wide, listening to the planet's gentle murmur. It's a conversation we'll never fully hear, but one that connects these gentle giants to the very heartbeat of the world. Every raindrop that falls has traveled the world before reaching you. The water that lands softly on your window or nurtures the garden outside has been on an incredible journey. That single drop may have once flowed through ancient rivers, rested in mountain lakes, or drifted as vapor above tropical seas. It could have nourished dinosaurs millions of years ago, filled the wells of medieval villages, or sparkled as morning dew on flowers that bloomed before you were born. Water doesn't age or wear out. It simply moves in an endless, patient cycle, carrying with it the quiet history of everywhere it has been. Each gentle shower is a reunion with travelers from across time and space. Mountains grow so slowly you could never notice, even in a lifetime. The Himalayas rise about 2 centimeters each year, pushed upward by the slow collision of massive tectonic plates. That's roughly the speed at which your fingernails grow. Yet this imperceptible movement has built the tallest peaks on Earth. Mount Everest wasn't always the world's highest mountain, and it won't always hold that title. The Earth reshapes itself with infinite patience, one microscopic push at a time. In the span of human life, mountains seem eternal and unchanging, but they're actually flowing upward like slow rivers of stone, reaching toward the sky with the gentlest persistence imaginable. Trees share nutrients with their neighbors through underground networks. Beneath the forest floor lies a hidden internet made of fungal threads finer than spider silk. These delicate filaments, called mycorrhizae, connect the roots of trees across entire woodlands, creating a web of communication and cooperation. Through this network, a healthy oak might send sugars to a struggling maple. An ancient pine could share minerals with its offspring, When one tree is attacked by insects, it can send chemical warnings to others, allowing them to prepare their defenses. This underground network operates in whispers, in the patient exchange of nutrients and information. The forest isn't a collection of individuals competing for resources. It's a quiet community, sharing and caring in ways we're only beginning to understand. Clouds are born from the breath of plants. On a summer morning, when mist rises gently from meadows and forests, you're witnessing one of nature's most beautiful partnerships. Plants release water vapor through tiny pores in their leaves, a process called transpiration. This invisible breath rises into the atmosphere, where it cools and condenses into droplets that form clouds. The Amazon rainforest creates about half of its own rainfall this way, breathing moisture into the sky that returns as gentle showers. Every leaf is a small factory of clouds, quietly exhaling the water that will someday fall as rain to nourish the earth below. In this way, plants don't just depend on weather. They help create it, one soft breath at a time. The ocean has rivers flowing within it that are larger than the Amazon. Deep beneath the surface of the sea, massive currents of cold, dense water flow like underwater rivers. The largest of these is the Antarctic Circumpolar Current, which carries more water than all the world's rivers combined. These oceanic streams move slowly and steadily, transporting heat, nutrients, and life across the globe. They operate on a scale so vast that they influence weather patterns thousands of miles away. Yet they flow in silence, invisible to those of us above the waves. The ocean isn't a static body of water. It's a living system of circulation, breathing and flowing with rhythms that have continued for millions of years. Sand dunes sing lullabies in the desert wind. In certain deserts around the world, when conditions are just right, sand dunes produce haunting musical tones. These singing sands, found in places like the Sahara and the dunes of California's Death Valley, create low, resonant hums that can last for several minutes. The sound occurs when millions of sand grains slide down the dune's face, vibrating in harmony like a vast, natural organ. The pitch depends on the size and shape of the grains, the moisture in the air, and the angle of the slope. Desert travelers have reported hearing these ethereal songs carried on the wind, a reminder that even the most barren landscapes have their own quiet music. Butterflies taste with their feet and smell with their antennae. These delicate creatures experience the world in ways we can barely imagine. When a butterfly lands on a flower, it's not just resting. Its feet contain taste receptors that can instantly determine whether the plant is suitable for laying eggs or gathering nectar. Meanwhile, its antennae detect chemical messages floating on the breeze, picking up the scent of flowers from miles away, or recognizing the pheromones of potential mates. A butterfly's entire body is a sophisticated sensory instrument, designed to navigate a world of subtle signals and chemical conversations. They live in a reality painted with flavors and fragrances, experiencing beauty in dimensions beyond our perception. The Earth's magnetic field protects us like an invisible shield. High above the atmosphere, our planet generates a gentle magnetic cocoon that deflects harmful radiation from space. This magnetic field, created by the churning of molten iron in Earth's core, extends thousands of miles into space, creating a protective bubble around our world. Without it, the solar wind would gradually strip away our atmosphere, leaving Earth as barren as Mars. The magnetic field is constantly shifting and fluctuating, sometimes weakening, sometimes strengthening. But it has been our silent guardian for billions of years, allowing life to flourish under its invisible protection. We rarely think about it, but this magnetic embrace keeps us safe every moment of every day. Ancient trees hold libraries of climate history in their rings. Every year, a tree adds a new ring to its trunk, and within those rings lies a detailed record of the weather it experienced. Wide rings indicate years of abundant rainfall and favorable growing conditions. Narrow rings reveal times of drought or stress. Some trees, like the bristlecone pines of California, have been keeping these records for over 4,000 years. Scientists can read these wooden chronicles to understand climate patterns from long before human records began. Each ring is like a page in a slow-growing book, written in wood and time, preserving memories of ancient summers and winters in the patient grain of living timber. The deepest parts of the ocean remain more mysterious than the surface of Mars. Less than 5% of Earth's oceans have been explored by humans. The deep sea, beginning just a few hundred meters below the surface, is a realm of eternal darkness, crushing pressure, and strange beauty. Here, creatures create their own light through bioluminescence, painting the black water with living stars. Giant tube worms cluster around underwater volcanoes, thriving in conditions that would be lethal to most life forms. Jellyfish the size of dinner plates drift through the abyss like translucent ghosts. Despite covering more than 70% of our planet's surface, the ocean depths remain largely unknown, holding secrets and wonders we're only beginning to discover. Honeybees dance to share directions with their sisters. When a scout bee discovers a promising patch of flowers, she returns to the hive with more than just nectar. She performs an intricate dance on the vertical surface of the honeycomb, waggling her abdomen and tracing figure-8 patterns. The angle of her dance indicates the direction of the flowers relative to the sun. The duration of her waggle and run tells her sisters how far they need to fly. The vigor of her movements conveys the quality of the nectar source. Other bees gather around to watch and learn, sometimes even following the dancer to better understand the message. It's a sophisticated form of communication that turns the hive into a living map, with each bee contributing to the collective knowledge of their foraging territory. Snowflakes form in patterns too complex for any two to be identical. High in the atmosphere, water vapor condenses around tiny particles of dust or pollen, beginning the intricate process of snowflake formation. As each crystal falls through layers of air with different temperatures and humidity levels, it grows in unique ways. The six-sided symmetry emerges from the molecular structure of ice, but the specific patterns, branches, and details depend on the exact conditions the snowflake encounters during its journey to Earth. Temperature variations of just a few degrees, slight changes in humidity, or different air currents all influence the final design. By the time a snowflake reaches the ground, it has become a tiny work of art, shaped by the atmospheric conditions of its particular path through the sky. The aurora borealis is Earth painting with solar wind. When charged particles from the sun collide with our planet's magnetic field, they create one of nature's most spectacular light shows. These particles, traveling at incredible speeds, are channeled by Earth's magnetism toward the polar regions, where they interact with gases in the upper atmosphere. Oxygen produces green and red lights, while nitrogen creates blues and purples. The result is a shimmering curtain of color that dances across the night sky, flowing and shifting like liquid light. Indigenous peoples of the Arctic have many names for these lights, often seeing them as the spirits of ancestors or the pathway to the afterlife. The aurora is Earth's way of making visible the invisible forces that surround our planet, transforming solar energy into pure beauty. Rivers carve canyons with the patience of geological time. The Grand Canyon, one of Earth's most spectacular features, was carved by the Colorado River over the course of millions of years. Water, moving grain by grain of sand and pebble by pebble, slowly wore through layers of rock that tell the story of ancient seas, deserts, and forests. What seems like solid, permanent stone yields to the gentle but persistent flow of water. The river didn't hurry. It simply flowed, day after day, year after year, century after century, carrying away tiny fragments and gradually revealing the colorful geological history hidden in the rock layers. The canyon stands as a testament to the power of patience, showing how the softest force on Earth can reshape the hardest materials given enough time. Forests create their own weather systems. Large woodlands don't just respond to climate, they actively influence it. Through the process of evapotranspiration, forests release enormous amounts of water vapor into the atmosphere. This moisture rises, cools, and forms clouds that bring rain back to the forest. The Amazon rainforest recycles rainfall multiple times as it moves from east to west across South America. Trees also moderate temperature, creating cooler microclimates beneath their canopies. Their leaves filter sunlight, their roots prevent erosion, and their presence slows wind speeds. A mature forest is like a living air conditioner, naturally regulating temperature and humidity across the landscape. The Earth spins at just the right speed to keep us comfortable. Our planet completes one rotation every 24 hours, a pace that creates the perfect rhythm of day and night for life as we know it. If Earth spun much faster, the days would be too short for plants to photosynthesize effectively, and the increased centrifugal force might reshape the planet's surface. If it spun more slowly, one side would bake in continuous sunlight, while the other froze in permanent darkness. The 24-hour day allows for the gradual warming and cooling cycles that drive weather patterns, ocean currents, and seasonal changes. This steady rotation, neither too fast nor too slow, helps maintain the delicate balance that makes our world so hospitable to life. Coral reefs build themselves from billions of tiny architects working in harmony. Each coral polyp is no larger than a pinhead, yet together they construct some of the most magnificent structures on Earth. These small animals extract calcium carbonate from seawater, secreting it to form their skeletal homes. Over thousands of years, countless generations build upon the foundations laid by their predecessors, creating vast underwater cities. The Great Barrier Reef, visible even from space, was built entirely by these microscopic creatures working with infinite patience. Each polyp contributes its small part to something far greater than itself, a living monument to the power of collective effort. In the warm, clear waters of tropical seas, these tiny builders continue their work, adding grain by grain to structures that have grown for millennia. Moths navigate by the light of the moon and stars. Long before humans invented compasses, night-flying moths developed their own celestial navigation system. They use the moon's steady light as a reference point, maintaining a constant angle to its glow as they travel. This works perfectly in nature, where the moon is infinitely distant and its light rays are essentially parallel. However, artificial lights confuse this ancient system. A moth approaching a street light or candle tries to maintain the same angle to this much closer light source, causing it to spiral inward in an ever-tightening circle. This behavior, which seems so puzzling to us, is actually evidence of an elegant navigation method that has guided moths across continents for millions of years. Underground, vast networks of caves breathe with the tides. Many cave systems near coastlines are connected to the ocean through hidden passages in the rock. As tides rise and fall, air pressure within these caves changes, causing them to literally breathe. Air flows in and out of cave entrances with a rhythm that matches the pulse of the sea. Some caves exhale warm, moist air during low tide and inhale cool air when the tide rises. This breathing can be so pronounced that explorers feel steady breezes flowing through passages deep underground. The caves become living lungs in the Earth's body, expanding and contracting with the rhythm of the ocean, connected to the sea by pathways carved through solid rock over countless centuries. Seeds can wait decades for the perfect moment to grow. In the soil beneath your feet lie countless seeds in various states of dormancy, some waiting years or even decades for ideal conditions. The seeds of some desert wildflowers remain viable for 20 years or more, patiently enduring droughts until sufficient rainfall triggers their germination. Fire-adapted plants produce seeds that only sprout after experiencing the heat and smoke of a wildfire, ensuring their offspring will have a cleared landscape and nutrient-rich ash in which to grow. Each seed contains not just the genetic blueprint for a new plant, but also the wisdom to know when the time is right. They are tiny time capsules of life, programmed to wait with perfect patience until their moment arrives. The planet's heartbeat can be heard in the rhythm of ocean waves. Every coastline experiences a unique pattern of wave action, influenced by wind, weather, underwater topography, and the shape of the seafloor. These patterns create natural rhythms that remain remarkably consistent over long periods. The average time between wave crests, the height of typical swells, and the seasonal variations in wave energy all contribute to each coast's distinctive pulse. Surfers and sailors learn to read these rhythms, understanding that each beach has its own personality shaped by the deep ocean's moods. The waves that arrive at any shore have traveled across thousands of miles of open water, carrying with them the energy of distant storms and the accumulated power of the sea's eternal motion. Crystals grow in the darkness of caves like frozen flowers. Deep within the earth, where water seeps slowly through limestone and other minerals, nature creates some of its most delicate artwork. Cave formations called flowstone cascade down walls like frozen waterfalls. Stalactites hang from ceilings like stone icicles, growing drop by drop over thousands of years. Delicate formations called cave flowers bloom in chambers that have never seen sunlight, their petals made of crystallized minerals. Each formation requires perfect conditions and immense patience. A stalactite might grow only a few millimeters per century, yet given enough time, these slow processes create underground cathedrals of breathtaking beauty. In complete darkness, chemistry and physics collaborate to build wonders that rival any human architecture. Migrating birds carry tiny magnetic compasses in their beaks. Scientists have discovered that many bird species possess magnetite crystals in specialized cells within their beaks and inner ears. These biological compasses allow birds to sense Earth's magnetic field and navigate across vast distances with remarkable precision. Arctic terns make annual migrations from Arctic to Antarctic, covering roughly 44,000 miles in their round trip. They navigate using not just the magnetic field, but also the position of the sun and stars, the polarization of light, and even infrasound from ocean waves. Young birds learn these navigation skills partly through instinct and partly by following experienced adults, creating a tradition of knowledge passed down through generations of travelers. The atmosphere protects us with layers as delicate as soap bubbles. Earth's atmosphere extends hundreds of miles above the surface, but most of the air we breathe is contained within the first 10 miles. This thin envelope of gases, if the Earth were the size of an apple, would be thinner than the apple's skin. Yet within this fragile boundary, complex layers work together to sustain life. The troposphere holds our weather. The stratosphere contains the ozone layer that filters harmful radiation. The mesosphere burns up meteors before they can reach the surface. Each layer has its own temperature, density, and characteristics, creating a sophisticated system that has maintained the delicate balance necessary for life to flourish for billions of years. Glaciers move like rivers of ice in slow motion. Though they appear solid and motionless, glaciers are actually flowing rivers of ice that move imperceptibly down mountainsides and through valleys. The immense weight of accumulated snow and ice causes the glacier to deform and flow, following the contours of the landscape beneath. Some glaciers move only a few inches per year, while others advance several feet daily. As they flow, glaciers carve valleys, transport enormous boulders, and reshape entire mountain ranges. They operate on a timescale so slow that their movement is nearly invisible to human perception, yet they possess enough power to sculpt continents. These frozen rivers carry within them the compressed snow of countless winters, preserving atmospheric samples from hundreds or thousands of years ago. Every grain of sand on every beach has its own geological story. The white sand of tropical beaches is often composed of broken coral and crushed shells, the remains of countless sea creatures that lived and died in ancient reefs. Black sand beaches form from volcanic glass, created when lava flows meet the sea and shatter from rapid cooling. Desert sand travels incredible distances on wind currents, sometimes crossing entire continents before settling into new dunes. Quartz sand grains, among the most durable, may have weathered from granite mountains, traveled down rivers, and been polished by waves for millions of years before reaching their current resting place. Each beach is a collection of geological stories, written in grains too small to read individually, but telling epic tales of Wakash, and viewed as a whole. Deep beneath the surface, the Earth generates its own heat from radioactive decay. The planet's core remains molten, not just from leftover heat from Earth's formation, but from the ongoing decay of radioactive elements like uranium, thorium, and potassium scattered throughout the rock. This internal heat engine drives plate tectonics, powers volcanic activity, and maintains the magnetic field that protects us from space radiation. Hot springs and geysers are windows into this subterranean energy source, bringing the Earth's internal warmth to the surface. In some places, this geothermal energy has been tapped to heat homes and generate electricity, using the planet's own internal fire to power human civilization. The Earth beneath our feet is not cold and dead, but warm and alive with slow-burning nuclear reactions. Flowers have evolved countless strategies to attract their perfect pollinators. Some orchids mimic the appearance and scent of female insects so precisely that male insects attempt to mate with them, inadvertently collecting pollen in the process. Night-blooming cereus flowers open only in darkness, releasing intense fragrances to attract nocturnal moths and bats. Sunflowers track the movement of the sun across the sky throughout the day, a behavior called heliotropism that ensures they maximize their exposure to sunlight. Some flowers change color after being pollinated, signaling to pollinators that their nectar has already been collected. Each species has evolved its own sophisticated advertising strategy using color, scent, shape, and timing to communicate with the specific creatures that can help them reproduce. The water cycle operates as Earth's circulatory system, distributing life across the planet. Water evaporates from oceans, rivers, and lakes, rises into the atmosphere, and travels vast distances before returning to Earth as precipitation. This system redistributes not just water, but also heat, minerals, and nutrients across the globe. Tropical rains may carry water that evaporated from polar seas. Desert winds transport moisture that originated in distant rainforests. The same water molecules that nourish plants in one ecosystem may later support life in an entirely different biome thousands of miles away. This global circulation system operates continuously, powered by solar energy and gravity, connect to every watershed on Earth in an intricate network of atmospheric rivers and oceanic currents. Lightning creates glass sculptures in the sand where it strikes. When lightning bolts hit sandy beaches or desert dunes, the intense heat instantly melts the silica in the sand, creating branching tubes of natural glass called fulgurites. These delicate structures, sometimes called petrified lightning, can extend several feet underground, following the path the electrical discharge took through the sand. Each fulgurite is a unique sculpture, hollow and fragile, preserving the exact moment when sky touched Earth with temperatures hotter than the surface of the sun. Beach walkers occasionally discover these glass treasures half buried in dunes, smooth and twisted like frozen branches of electricity. They are nature's way of turning a moment of violence into something beautiful, transforming raw energy into art that can last for thousands of years. Whales sing lullabies that travel across entire ocean basins. The low-frequency calls of blue whales, the largest animals ever to live on Earth, can travel for thousands of miles through deep ocean waters. These haunting songs, pitched below the range of human hearing, serve as long-distance communication between individuals separated by vast stretches of sea. Humpback whales compose complex melodies that evolve and change over time, with new phrases spreading through populations like musical trends. Each whale population has its own dialect, and young whales learn songs from their elders, creating cultural traditions that pass through generations. In the deepest parts of the ocean, these gentle giants maintain conversations across distances that would span entire continents. Their voices, carried by the sea's natural acoustic channels, mushrooms are the flowers of vast underground organisms. What we see above ground as a mushroom is only a tiny fraction of the fungal organism beneath. The main body of the fungus consists of thread-like structures called mycelium that spread through soil, fallen logs, and organic matter, sometimes covering many acres. These underground networks can live for hundreds or even thousands of years, quietly decomposing organic material and recycling nutrients back into the ecosystem. When conditions are right, the mycelium sends up mushrooms like fruit on a tree, releasing spores to start new colonies. Some of the largest living organisms on Earth are fungi, their bodies hidden beneath the forest floor, connecting and nourishing the woodland community in ways we're only beginning to understand. Tides are caused by the moon's gentle pull on our planet's waters. As Earth rotates, the moon's gravity creates a subtle but persistent tug on our oceans, drawing water toward the side facing the moon while causing it to bulge away on the opposite side. This creates the twice-daily rhythm of high and low tides that has shaped coastal life for millions of years. The sun also influences tides, and when sun and moon align, their combined pull creates especially high spring tides. When they work at cross purposes, we get gentler neap tides. This celestial dance affects not just the height of water at the shore, but also the behavior of countless marine creatures that time their feeding, mating, and migration to the tidal rhythm. Soil takes thousands of years to form from solid rock. The ground beneath your feet represents millions of years of patient weathering. Rain, wind, temperature changes, and living organisms slowly break down solid rock into smaller and smaller particles. Lichens growing on bare stone produce weak acids that gradually dissolve minerals. Plant roots growing into cracks expand and contract with the seasons, slowly splitting rocks apart. Earthworms, insects, and countless microorganisms mix decaying organic matter with these mineral particles, creating the rich, living soil that supports terrestrial life. A single inch of topsoil may represent centuries of this slow transformation, making fertile ground one of Earth's most precious and slowly renewable resources. Bioluminescent waves turn shorelines into liquid starlight. In certain coastal waters around the world, microscopic organisms called dinoflagellates create spectacular displays of blue-green light when disturbed by waves or movement. These tiny creatures emit light as a defense mechanism, startling predators with sudden flashes of bioluminescence. When millions of them are present in the water, every wave that breaks on the shore glows with an ethereal blue light. Swimmers moving through the water leave trails of sparkles behind them, and each footstep in the wet sand triggers tiny explosions of living light. This phenomenon occurs most commonly in warm tropical waters, turning night swimming into a magical experience, where the boundary between sea and sky seems to dissolve in gentle glow-ing waves. Spider webs are architectural marvels stronger than steel. The silk that spiders spin from their bodies is one of nature's most remarkable materials, combining incredible strength with extraordinary flexibility. Pound for pound, spider silk is stronger than steel and more elastic than rubber. Each web is a precisely engineered structure, with different types of silk used for different purposes. The outer frame provides structural support, while the sticky spiral threads capture prey. Some spiders rebuild their entire web each night, recycling the silk by eating the old web before spinning a new one. The geometric precision of orb weaver webs, the funnel designs of grass spiders, and the chaotic tangles of cobweb spiders all represent different solutions to the challenge of catching flying insects. The northern lights have southern twins called aurora australis, while the aurora borealis dances across northern skies. An equally spectacular light show occurs around the South Pole. The aurora australis mirrors its northern counterpart, created by the same solar particles interacting with Earth's magnetic field. These southern lights shimmer over Antarctica and the Southern Ocean, visible from southern Argentina, Chile, Australia, and New Zealand during periods of high solar activity. The two auroras often occur simultaneously, connected by the magnetic field lines that channel solar particles toward both poles. Indigenous peoples of the Southern Hemisphere have their own rich traditions and stories about these lights, seeing in them the spirits of ancestors or the dancing of celestial beings across the star-filled southern sky. Ancient air bubbles trapped in ice tell stories of past atmospheres. Deep within the ice sheets of Greenland and Antarctica, scientists can read the atmospheric history of our planet. As snow falls and compresses into ice over thousands of years, it traps tiny bubbles of ancient air. By drilling ice cores and analyzing these bubbles, researchers can determine the concentration of greenhouse gases, the temperature, and even the volcanic activity that occurred hundreds of thousands of years ago. Each layer of ice represents 1 year's snowfall, creating a detailed timeline of Earth's climate that extends back nearly 1 million years. These frozen archives reveal how our atmosphere has changed over time and help us understand the natural rhythms of our planet's climate system. Hummingbirds are the only birds that can fly backwards and hover like helicopters. These tiny aviators have evolved flight capabilities that exceed those of any other bird. Their wings beat in a figure-8 pattern up to 80 times per second, creating lift on both the upstroke and downstroke. This allows them to hover motionless in front of flowers while feeding, fly straight up or down, and even fly backwards with perfect control. Their hearts beat over 1,000 times per minute, and their metabolism is so fast that they must consume their body weight in nectar every day. Despite weighing less than a penny, some hummingbirds migrate thousands of miles, including non-stop flights across the Gulf of Mexico. These jewel-like creatures represent the pinnacle of aerial agility in the natural world. River deltas create new land through the patient deposit of sediment. Where rivers meet the sea, They drop the sediment they've carried from far upstream, gradually building new land into the ocean. The Mississippi River Delta, the Nile Delta, and the Ganges Delta are all examples of this slow but steady process of land creation. Each flood brings new layers of fertile soil, building up the delta inch by inch over centuries. These deltaic regions become some of the most productive agricultural areas on Earth, their rich soils renewed annually by river floods. The branching patterns of delta channels, viewed from above, resemble the veins of a leaf or the branching of a tree, following mathematical laws that govern the flow of fluids through landscape. Honeybee colonies maintain their hive temperature with remarkable precision. Regardless of outside weather conditions, bees keep the interior of their hive at exactly 35 degrees Celsius, the optimal temperature for developing larvae and storing honey. In hot weather, worker bees collect water and fan their wings to create evaporative cooling, turning the hive into a living air conditioner. During cold periods, they cluster together and vibrate their flight muscles to generate heat, forming a warm, living blanket around their developing siblings. This temperature regulation requires constant cooperation and communication among thousands of individuals, each contributing to the collective effort of maintaining their home's perfect climate. The precision of this biological thermostat rivals any human technology. Rainbows appear when sunlight and rain create perfect partnerships in the sky. When the sun shines through water droplets in the air, each droplet acts as a tiny prism, separating white light into its component colors. The angle between the sun, your eye, and the water droplets must be exactly 42 degrees for you to see a primary rainbow. The colors always appear in the same order because each wavelength of light bends at a slightly different angle as it passes through the water droplets. Sometimes a fainter secondary rainbow appears above the primary one, with colors in reverse order. This happens when light bounces twice inside each water droplet before reaching your eyes. Double rainbows create a magical arch across the sky, a temporary bridge of pure color connecting Earth to sky. Deep-sea creatures create their own galaxies of living light in eternal darkness. In the deepest parts of the ocean, where sunlight never penetrates, life has evolved its own illumination. Jellyfish pulse with bioluminescent rhythms, creating moving constellations in the black water. Anglerfish dangle glowing lures to attract prey, while lanternfish form shimmering schools that look like underwater cities when viewed from submersibles. Some deep-sea creatures can control their bioluminescence like living neon signs, flashing complex patterns to communicate with others of their species. Others use light for camouflage, matching the faint glow filtering down from above to hide their silhouettes from predators below. In these dark depths, life has learned to paint with light, creating beauty in places where human eyes were never meant to see. Seasonal changes occur because Earth tilts gently on its axis as it orbits the sun. Our planet's 23.5-degree tilt means that different regions receive varying amounts of sunlight throughout the year. When the northern hemisphere tilts toward the sun, it experiences summer while the southern hemisphere has winter. 6 months later, the situation reverses. This gentle wobble in Earth's orientation creates the rhythm of seasons that has shaped life on our planet for billions of years. Without this tilt, there would be no spring awakening, no autumn colors, no winter rest. The same regions would experience the same weather year-round. Our tilted world gives us the gift of change, the poetry of seasons, and the endless cycle of renewal that makes each year a journey through different moods of light and weather. Forests communicate through chemical signals carried on the breeze. When a tree is attacked by insects or disease, it releases airborne chemicals that serve as warnings to neighboring trees. These chemical messages, called volatile organic compounds, drift through the forest on air currents, alerting other trees to increase their production of defensive compounds. Some trees can even identify the specific threat and tailor their chemical defenses accordingly. A maple tree being eaten by caterpillars will emit different warning chemicals than one infected by a fungal disease. This airborne communication network operates continuously throughout the forest, creating an invisible web of chemical conversations that helps the entire woodland community respond to threats and share information about environmental conditions. The Earth's rotation creates the gentle force that shapes weather patterns around the globe. As our planet spins, the Coriolis effect causes moving air and water to curve rather than travel in straight lines. This invisible force influences everything from the rotation of hurricanes to the direction of trade winds. In the northern hemisphere, storms rotate counterclockwise, while in the southern hemisphere they spin clockwise. Ocean currents bend and twist as they flow across the spinning planet, creating the great circulation patterns that distribute heat from the equator toward the poles. Even something as simple as water draining from a bathtub can show the subtle influence of Earth's rotation, though the effect is much more pronounced in large-scale weather systems that operate across hundreds of miles. Caves preserve perfect silence and constant temperatures year-round. Deep underground, beyond the reach of surface weather, caves maintain remarkably stable conditions. The temperature in most caves equals the average annual temperature of the region above ground, remaining constant regardless of seasonal changes outside. Some caves maintain the same temperature within a degree or two throughout the year, creating refuges where ancient ice persists even in temperate climates. The silence in deep caves is so complete that visitors often report hearing their own heartbeat and blood circulation. This acoustic isolation, combined with stable temperatures and high humidity, creates unique ecosystems where specialized creatures have evolved in eternal darkness and silence. Glacial ice contains bubbles of ancient atmosphere that sparkle like tiny diamonds. When you look closely at glacial ice, you can see thousands of tiny bubbles trapped within the frozen water. These bubbles contain samples of the atmosphere from when the ice first formed, sometimes thousands of years ago. As the ice moves and changes temperature, these ancient air pockets create internal stress that causes the ice to pop and crack, releasing sounds that glaciologists call ice music. The bubbles also give glacial ice its distinctive deep blue color and make it sparkle in sunlight like a frozen constellation. Each bubble is a tiny time capsule, preserving a breath of ancient air in crystalline form, waiting to tell its story to scientists who study climate history frozen in ice. Wind patterns follow invisible highways in the atmosphere created by temperature differences. Hot air rises from sun-warmed surfaces, while cool air flows in to replace it, creating circulation patterns that drive weather systems around the globe. These atmospheric rivers carry moisture from oceans to continents, bringing rain to regions thousands of miles from the nearest sea. The jet streams, rivers of fast-moving air high in the atmosphere, steer weather systems along predictable paths, though their exact routes shift with the seasons. Trade winds, monsoons, and prevailing westerlies all follow these invisible atmospheric highways, carrying not just weather, but also seeds, pollen, dust, and even small creatures across vast distances. The atmosphere moves in predictable patterns that connect every region of Earth in a global circulation system. Lichens are partnerships so successful they can survive in space. These remarkable organisms are actually two different life forms living together so intimately that they function as one. A fungus provides structure and protection, while an alga or cyanobacterium produces food through photosynthesis. This partnership is so successful that lichens can colonize bare rock, survive extreme cold and drought, and even endure the vacuum and radiation of outer space. They grow incredibly slowly, sometimes less than a millimeter per year, but can live for thousands of years. Lichens often serve as pioneer species, beginning the process of soil formation that eventually allows other plants to establish themselves. They paint rocks with splashes of orange, yellow, and gray, adding color to landscapes where few other organisms can survive. The ocean's deepest trenches remain largely unexplored frontiers on our own planet. The deepest point on Earth, the Challenger, deep in the Mariana Trench, plunges nearly 7 miles below sea level. The pressure at this depth is over 1,000 times greater than at sea level, equivalent to having 50 jumbo jets pressing down on every square meter. Despite these extreme conditions, life thrives even in these deepest places. Strange creatures adapted to crushing pressure and eternal darkness have been discovered in recent deep-sea expeditions. The water temperature near the bottom hovers just above freezing, yet hydrothermal vents create pockets of warmth that support unique ecosystems. These deep trenches represent some of the last unexplored regions on our planet, holding secrets about life's limits and the geological processes that shape our world. Tree rings not only record age but also preserve memories of ancient fires, droughts, and volcanic eruptions. Each annual growth ring tells a detailed story of the conditions the tree experienced during that particular year. Narrow rings indicate stress from drought or cold temperatures. Rings with unusual cell structures may record damage from fires that the tree survived. Sometimes rings contain particles of ash from distant volcanic eruptions, preserving evidence of major geological events. Scientists can cross-reference ring patterns from many trees to create detailed climate records extending back thousands of years. These wooden archives have revealed information about ancient droughts that lasted decades, medieval warm periods, and even the cooling effects of major volcanic eruptions that reduced global temperatures and caused crop failures in distant civilizations. Monarch butterflies navigate using an internal compass calibrated to the sun's position. Every autumn, millions of monarch butterflies embark on a migration that spans multiple generations and covers thousands of miles. Individual butterflies that have never made the journey before somehow know the exact route to follow to ancestral wintering grounds in Mexico. They navigate using the position of the sun, compensating for its movement across the sky with an internal clock that tracks the time of day. Their antennae contain magnetic sensors that may also help them orient to Earth's magnetic field. Most remarkably, the butterflies that return north in spring are not the same individuals that flew south. The migration is completed by their offspring and great offspring. Yet each generation instinctively knows the route that their ancestors traveled. Mountain springs emerge from underground rivers that have traveled for decades through hidden stone passages. Deep beneath mountain ranges, groundwater follows invisible pathways through fractured rock, sometimes journeying for 20 or 30 years before emerging as crystal-clear springs. These underground streams flow through limestone caverns, sandstone channels, and granite fissures, slowly filtering and purifying as they move through the Earth's natural filtration system. The water that bubbles up from a mountain spring today may have begun its underground journey when you were a child, traveling silently through darkness, gathering minerals that give it its distinctive taste, emerging finally into sunlight as pure and cold as liquid starlight. Penguins huddle together in perfectly organized spirals to share warmth during blizzards. In the harsh Antarctic winter, emperor penguins form large circular groups called huddles, with each bird taking turns moving from the cold exterior to the warm interior. These huddles rotate slowly, like a living carousel, ensuring that no individual penguin stays on the freezing edge for too long. The birds on the outside gradually shuffle toward the center, while those who have warmed up move outward, creating a continuous circulation that can keep the entire group alive during storms that would be fatal to solitary birds. The temperature difference between the center and edge of a huddle can be over 40 degrees, turning cooperation into a matter of life and death. Dewdrops form overnight as the earth exhales moisture into cooling air. As night falls and temperatures drop, the ground releases water vapor that has been stored in soil and plants throughout the warm day. This invisible breath rises only a few inches before encountering cooler air, where it condenses into perfect spherical droplets on grass, leaves, and spider webs. Each dewdrop acts as a tiny magnifying glass, bending light and creating miniature rainbows in the early morning sun. Desert plants have evolved to collect this moisture, with some cacti gathering enough water from dew alone to survive months without rain. The formation of dew is so predictable that ancient peoples used its presence or absence to forecast the weather for the coming day. Volcanoes create new islands through gentle underwater construction projects that last for millions of years. Far beneath the ocean's surface, underwater volcanoes slowly build themselves upward, one eruption at a time. Each lava flow adds a new layer to the growing mountain, gradually approaching the surface over thousands of years. When the volcano finally breaks through into air, it begins as a small rocky island, continuing to grow as more eruptions add land above sea level. The Hawaiian Islands were all born this way, built from the ocean floor by patient volcanic processes. Even now, new islands are under construction beneath the waves, their peaks still thousands of feet below the surface, quietly growing toward their eventual emergence into sunlight. Beaver dams create wetland ecosystems that can last for centuries after the beavers have moved on. When beavers build their stick and mud barriers across streams, they create ponds that attract dozens of other species. Waterfowl nest in the quiet waters, amphibians breed in the shallows, and fish find refuge in the deep pools. Over time, sediment accumulates behind the dam, creating rich organic soil. Even after the beavers abandon the site and the dam eventually breaks down, the wetland they created continues to support diverse plant and animal communities. Some beaver meadows in North America contain layers of sediment and organic matter that record thousands of years of beaver activity, showing how these industrious rodents have shaped entire landscapes through their construction projects. Arctic foxes change not just their coat color, but their entire metabolism with the seasons. As winter approaches in the far north, Arctic foxes don't simply grow thicker fur. Their entire physiology shifts to match the harsh conditions ahead. Their metabolic rate slows to conserve energy during the months when prey becomes scarce. Their kidneys become more efficient at concentrating urine to prevent water loss. Even their blood chemistry changes, with modifications that help prevent their extremities from freezing. In summer, the process reverses as their bodies prepare for the active hunting season. This seasonal transformation is so complete that summer and winter Arctic foxes are almost like different animals inhabiting the same body. Stalactites and stalagmites grow toward each other like stone lovers reaching across cave chambers. In limestone caves, these formations create some of nature's most patient romances. Stalactites hang from the ceiling, growing downward drop by drop as mineral-rich water seeps through the rock above. Directly below, stalagmites build upward from the cave floor, formed by the same water droplets as they splash and deposit their mineral cargo. Over thousands of years, these formations slowly reach toward each other across the dark space between. When they finally meet, they form a continuous column that connects floor to ceiling. Some caves contain hundreds of these stone pillars, created by water's quiet persistence and the slow chemistry of dissolved limestone. Hummingbird hearts are so efficient, they could power a helicopter if scaled up proportionally. These tiny birds possess the most powerful hearts in the animal kingdom, relative to their body size. A hummingbird's heart makes up about 2.5% of its total body weight and beats over 1,200 times per minute during flight. The heart muscle is so dense with energy-producing mitochondria that it appears almost black under a microscope. This incredible cardiovascular system allows hummingbirds to hover, dart, and maneuver with precision that exceeds the capabilities of most human-built aircraft. Their flight muscles make up nearly 30% of their body weight, and they can beat their wings up to 80 times per second without showing signs of fatigue. Sandhill cranes perform elaborate dances that strengthen family bonds and community ties. These graceful birds engage in complex choreographed displays that involve leaping, bowing, and synchronized movements that can last for hours. Young cranes learn these dances by watching and imitating their parents, gradually mastering the intricate steps that will help them attract mates and maintain social connections throughout their lives. The dances serve multiple purposes beyond courtship, helping to reduce aggression within flocks, establish social hierarchies, and strengthen pair bonds between mated couples. During migration stops, hundreds of cranes may gather in marshy areas, creating spectacular scenes as the entire flock participates in these ancient rituals. Redwood trees can live for over 2,000 years by sharing resources through their interconnected root systems. These ancient giants don't compete with each other for water and nutrients. Instead, their shallow root systems interweave to create a supportive network that can extend outward for 50 feet or more from each tree's base. When one tree is stressed by drought or disease, neighboring redwoods can share resources through root grafts and mycorrhizal connections, helping the struggling tree survive difficult periods. This cooperation allows redwood groves to persist through centuries of changing conditions, with some trees supporting others that might otherwise perish. The oldest redwoods have survived countless forest fires, droughts, and storms by maintaining these underground partnerships. Fireflies synchronize their flashing patterns to create living light shows across entire forests. In some species of fireflies, individuals gradually adjust their timing until entire trees pulse with coordinated light. This synchronization can spread across hillsides, creating waves of illumination that roll through the landscape like slow lightning. Scientists believe this coordination helps fireflies locate mates more easily by reducing the confusion of random flashing. Males and females of the same species can find each other more readily when the background noise of other flashing insects becomes organized into predictable patterns. The mathematics of this synchronization follow the same principles that govern other natural phenomena, from the coordinated firing of brain neurons to the collective behavior of cardiac pacemaker cells. Ocean currents transport heat around the globe like a vast liquid conveyor belt system. Warm water flows from equatorial regions toward the poles, while cold water sinks and flows back toward the equator at deeper levels. This global circulation pattern, known as thermohaline circulation, distributes tropical warmth to higher latitudes and brings cold, nutrient-rich water to surface regions where it supports marine ecosystems. The Gulf Stream, one component of this system, carries warm water northward along the eastern coast of North America, moderating the climate of Western Europe. Without this heat transport, London would have a climate similar to northern Canada, and many regions that are currently habitable would be locked in perpetual winter. Salmon remember the exact chemical signature of their birth streams through smell memories that last for years. After spending most of their adult lives in the ocean, salmon navigate back to the precise creek where they were born using their sense of smell. Each watershed has its unique chemical fingerprint created by the specific minerals, plants, and geological features in the drainage basin. Young salmon imprint on this chemical signature before migrating to sea, storing the information in specialized cells in their nasal passages. Years later, as mature adults, they can detect and follow this remembered scent across thousands of miles of ocean and up hundreds of miles of rivers to reach their exact birthplace. This chemical memory is so precise that salmon can distinguish between tributaries that differ by only slight variations in mineral content. Underground rivers flow beneath deserts, carrying water that fell as rain thousands of years ago. Deep aquifers in arid regions contain water that percolated down through soil and rock during ancient wet periods when the climate was very different. The Ogallala Aquifer beneath the American Great Plains holds water that accumulated during the last ice age. In the Sahara Desert, underground rivers flow beneath the sand, fed by rainfall that occurred when the region was green and lush 8,000 years ago. This fossil water moves incredibly slowly through underground rock formations, traveling perhaps only a few miles per century. Wells drilled into these ancient aquifers bring to the surface water that fell from skies before human civilization began, connecting us directly to the climate of a vanished world. Migratory birds use star patterns as navigation maps during nighttime flights. Many songbirds migrate at night when air conditions are calmer and there are fewer predators. They orient themselves using the rotating pattern of stars, with different species focusing on different celestial landmarks. Young birds learn these star maps through a combination of genetic programming and experience, developing an internal star compass that remains accurate throughout their lives. Even on overcast nights, many birds can navigate using polarized light patterns that are invisible to human eyes, but clearly visible to their specially adapted vision. This celestial navigation system is so precise that birds can maintain straight-line courses across thousands of miles of open ocean or featureless terrain. Ancient forests preserve climate records in the growth patterns of their slowest-growing trees. Bristlecone pines, some of the oldest living organisms on Earth, add only tiny amounts of wood each year, creating rings so narrow they must be measured under microscopes. These ancient trees, growing in harsh mountain environments where few other plants can survive, respond sensitively to small changes in temperature and moisture. Their growth rings preserve detailed records of climate variations extending back over 4,000 years. Scientists use these living archives to understand natural climate cycles, volcanic winters caused by major eruptions, and even the effects of distant phenomena like changes in solar radiation. Each microscopic ring represents 1 year in the life of a tree that was already ancient when Egyptian pyramids were being built. Whirlpools form in rivers and oceans following mathematical patterns that appear throughout nature. These spinning vortices follow the same geometric principles that govern the spiral arrangements of seeds in sunflower heads, the curves of nautilus shells, and the rotation of galaxies. Water flowing past obstacles or through narrow channels naturally organizes itself into these rotating patterns, which are among the most efficient ways to dissipate energy in moving fluids. Small whirlpools in streams follow the same mathematical laws as massive oceanic gyres that span entire ocean basins. The spiral patterns that emerge from these fluid dynamics appear at every scale in nature, from the microscopic vortices in flowing blood to the enormous rotating storms visible from space. Night-blooming flowers release their fragrances in carefully timed pulses to attract specific pollinators. Evening primrose, night-blooming cereus, and other nocturnal flowers don't simply emit constant scents. Instead, they release bursts of fragrance at precise intervals that correspond to the activity patterns of their target pollinators. Some flowers increase their scent production just as their preferred moth or bat species begins its nightly foraging, Others pulse their fragrance in rhythms that help pollinators locate them more easily in darkness. The chemistry of these nighttime perfumes is often completely different from day-blooming flowers, featuring compounds that travel farther in cool night air and remain detectable for longer periods. Glacial valleys were carved by rivers of ice that flowed like thick honey over thousands of years. Unlike the sharp, V-shaped valleys cut by water erosion, glacial valleys have distinctive U-shaped profiles created by the grind and action of moving ice. As glaciers advanced and retreated over multiple ice ages, they carved these broad valleys, polished rock surfaces to mirror smoothness, and transported enormous boulders hundreds of miles from their origins. The Yosemite Valley, carved by glaciers that disappeared thousands of years ago, still shows the distinctive marks of ice erosion in its granite walls. These glacial signatures remain visible long after the ice has melted, preserving evidence of ancient climate conditions in the very shape of the landscape. Bees perform temperature-sensitive dances that become more vigorous as the weather warms. The famous waggle dance that bees use to communicate flower locations varies with environmental conditions. On cool mornings, the dances are slower and less energetic, while warm afternoons inspire more vigorous performances. The bees also adjust their dance intensity based on the quality of the nectar source they've discovered, with richer flower patches inspiring more enthusiastic dances that attract more followers. These dance variations help the colony allocate its foraging effort efficiently, sending more workers to the best food sources during optimal flying conditions. The hive's collective decision-making process emerges from thousands of individual dance performances, creating a distributed intelligence that rivals any computer algorithm. Sand dunes migrate across landscapes like slow-motion waves, reshaping entire regions over centuries. Wind-driven sand moves in predictable patterns, with grains rolling up the gentle windward slope of each dune and cascading down the steep slip face on the lee side. This constant motion causes entire dunes to advance in the direction of prevailing winds, sometimes traveling several miles per year. Ancient dunes buried by vegetation can be reactivated during droughts, emerging from beneath forests and grasslands to resume their slow march across the landscape. Archaeological sites are sometimes revealed and then covered again as migrating dunes expose and bury evidence of past human settlements. These moving mountains of sand follow the wind like solid clouds, reshaping the Earth's surface with patient persistence. Root systems extend far deeper underground than most people realize, creating hidden forests beneath the visible landscape. Prairie grasses send roots down 15 feet or more, storing carbon deep in the soil and accessing water from underground sources. Tree roots commonly extend twice as far horizontally as the tree is tall, and some species send tap roots down over 100 feet to reach groundwater. This underground architecture is often more massive than the visible portions of plants, with some trees investing more energy in root growth than in above-ground structures. The hidden root networks create extensive underground ecosystems that support soil microorganisms, fungi, and countless small animals that spend their entire lives in the spaces between roots. Meteor showers occur when Earth passes through the debris trails left by ancient comets. As comets orbit the Sun, They shed particles of dust and ice that spread out along their orbital paths, creating invisible highways of cosmic debris. When Earth's orbit intersects these particle streams, the debris enters our atmosphere and burns up as shooting stars. Each meteor shower follows a predictable annual schedule because Earth encounters the same comet trails at the same time each year. The Perseid meteor shower in August comes from debris left by comet Swift-Tuttle, while the December Geminids originate from an unusual asteroid that may be an extinct comet. These celestial light shows connect us to the deep history of our solar system, allowing us to witness the slow disintegration of ancient comets that have been orbiting the sun for millions of years. Hibernating animals survive winter by becoming living examples of suspended animation. Bears, ground squirrels, and other hibernating mammals slow their heart rates to just a few beats per minute and drop their body temperatures close to freezing. Their breathing becomes so shallow, it's barely detectable, and their metabolism slows to a fraction of its normal rate. Some hibernating animals don't wake up for months, surviving entirely on stored body fat, while their organs continue functioning at the minimum level necessary to sustain life. This biological time slowing allows them to wait out harsh winters when food is scarce, emerging in spring as if awakening from a deep dream that lasted half a year. Earthquake waves travel through the Earth like ripples in a solid pond, revealing the planet's hidden internal structure. When earthquakes occur, they generate several types of waves that move at different speeds through different materials. Primary waves compress and stretch rock as they pass, while secondary waves shake it from side to side. These seismic waves slow down, speed up, or change direction when they encounter different types of rock, boundaries between layers, or pockets of liquid deep underground. By studying how earthquake waves behave as they travel through the planet, scientists have mapped the Earth's internal structure without ever drilling deeper than a few miles. This seismic imaging has revealed the liquid outer core, the solid inner core, and the complex layering of the mantle that lies beneath our feet. Coral polyps build reefs by extracting calcium from seawater and combining it with carbon dioxide to create limestone. Each tiny coral animal, no bigger than a pencil eraser, constructs its own cup-shaped skeleton by precipitating minerals directly from the surrounding ocean. Over time, countless generations of polyps build upon the skeletons of their predecessors, creating massive reef structures that can be seen from space. The process requires precise water chemistry, with corals thriving only in narrow ranges of temperature, salinity, and acidity. Climate change is altering ocean chemistry in ways that make it harder for corals to build their skeletons, threatening these underwater cities that took thousands of years to construct. Each coral reef represents millions of years of patient biological architecture, built one microscopic skeleton at a time. Seeds travel the world on invisible highways of wind, water, and animal messengers. Dandelion seeds drift on feathery parachutes that can carry them hundreds of miles from their parent plants, following air currents that lift them high into the atmosphere. Some seeds are equipped with wings, hooks, or sticky surfaces that allow them to hitchhike on passing animals, traveling vast distances in fur, feathers, or digestive systems. Coconuts float across oceans for months, their waterproof shells protecting the embryo inside, until they wash ashore on distant beaches thousands of miles from where they fell. Each dispersal method represents a different strategy for colonizing new territories, with some seeds remaining viable for decades while they wait for the perfect conditions to germinate in their new homes. Glacial meltwater carries minerals that have been locked in ice for thousands of years. As ancient ice slowly melts, it releases nutrients that were trapped when the ice first formed, creating some of the most mineral-rich water on Earth. This glacial flower, as it's called, gives meltwater streams their distinctive milky blue-green color and provides essential nutrients to downstream ecosystems. Rivers fed by glacial meltwater support unique communities of plants and animals adapted to the cold, mineral-rich conditions. The timing of glacial melt also regulates water flow in many mountain regions, with the slow release of stored ice providing steady stream flow throughout the dry summer months. Mushroom spores are among the most widely traveled organisms on Earth, drifting across continents in high-altitude air currents. These microscopic reproductive cells are so light and durable that they can remain suspended in the atmosphere for weeks, crossing oceans and mountain ranges before settling in suitable habitats. Some mushroom species found on isolated islands are genetically identical to populations on distant continents, evidence of their incredible dispersal abilities. Spore clouds can be detected miles above the Earth's surface, and some scientists believe that mushroom spores may even survive the journey through outer space, potentially seeding life on other planets if conditions are suitable. Geothermal hot springs create oases of warmth that support tropical plants in Arctic climates. In places like Iceland and Yellowstone, hot water heated by underground volcanic activity emerges at temperatures that remain constant year-round, creating microclimates that exist independent of seasonal weather patterns. These thermal refugia allow heat-loving plants and animals to survive far north of their normal ranges, creating pockets of biological diversity in otherwise harsh environments. Some hot springs maintain water temperatures of over 180 degrees Fahrenheit throughout the winter, creating steam clouds that can be seen for miles in frigid air. Sand grains journey across entire continents, carrying stories written in their mineral composition and surface textures. Saharan dust travels across the Atlantic Ocean, fertilizing Amazon rainforests with iron and phosphorus essential for plant growth. Each grain bears the microscopic scars of its journey, with rounded edges indicating long transport by wind or water, while angular fragments suggest recent weathering from parent rocks. Geologists can read these mineral signatures like fingerprints, tracing sand grains back to their original mountain sources and mapping the ancient pathways of wind and water that transported them across vast distances. Thermal vents on the ocean floor create underwater gardens where life thrives without sunlight. These deep-sea oases, heated by volcanic activity beneath the sea floor, support ecosystems based entirely on chemosynthesis rather than photosynthesis. Giant tube worms, ghostly white crabs, and bacterial mats flourish around these vents, creating islands of life in the deep ocean desert. The water emerging from these vents can reach temperatures of over 700 degrees Fahrenheit, hot enough to melt lead, Yet just feet away, the surrounding ocean remains near freezing. These extreme gradients create unique habitats where organisms have evolved remarkable adaptations to survive in conditions unlike anywhere else on Earth. Valley fog forms when cool air settles into low-lying areas like a gentle blanket covering the landscape. As night falls and the ground radiates heat into space, cold air becomes denser and flows downhill, pooling in valleys and creating layers of mist that can persist for hours after sunrise. This fog creates its own microclimate, moderating temperature extremes and providing moisture for plants even during dry periods. Redwood forests depend on this fog for much of their water needs, with specialized needles that comb moisture directly from the air. The slow movement of fog through valleys creates ethereal landscapes where hilltops emerge like islands from a sea of mist. Beaver-modified landscapes continue to influence water flow patterns long after the engineers have departed. The stick and mud dams built by these industrious rodents create terraced wetlands that slow water flow, reduce erosion, and recharge groundwater aquifers. Even after abandonment, these structures continue to function for decades, gradually evolving into meadow ecosystems as sediment fills the former ponds. The stepped profile created by multiple beaver dams along a single stream can extend the benefits of flood control and water storage across entire watersheds. Archaeological evidence suggests that some beaver meadows in North America have been continuously maintained for over 1,000 years. Desert cacti demonstrate remarkable engineering solutions for water collection and storage. Their accordion-like stems expand to hold water during rare rainfall events, while their waxy coatings prevent moisture loss during extended dry periods. The spines that cover most cacti serve multiple functions beyond defense, creating tiny wind shadows that reduce water loss and collecting dew that drips down to the roots. Some species have evolved specialized root systems that spread horizontally just beneath the surface, allowing them to quickly absorb water from light rains before it evaporates. These adaptations allow cacti to thrive in environments where most plants would quickly perish. Subterranean rivers carve cathedral-sized chambers through solid limestone over millions of years. The patient action of slightly acidic water dissolves calcium carbonate, creating vast underground spaces decorated with flowstone formations that rival any human architecture. These hidden chambers often contain underground lakes of crystal-clear water that reflect stone formations in perfect mirror images. The constant temperature and humidity in deep caves create stable environments where delicate formations can grow undisturbed for thousands of years. Some cave systems extend for hundreds of miles underground, connecting distant surface features through hidden aquatic highways. Pollinating bats navigate using both echolocation and scent to find night-blooming flowers in complete darkness. These aerial mammals have co-evolved with desert plants that open their flowers only at night, timing their nectar production to coincide with peak bat activity. The flowers often have a musty, yeast-like scent that appeals specifically to bats, along with pale colors that reflect moonlight to make them more visible in darkness. Some bat-pollinated plants position their flowers away from foliage to provide clear flight paths for their winged visitors. This nocturnal partnership allows desert ecosystems to maintain pollination services during cool nighttime hours when daytime pollinators are inactive. Meandering rivers create oxbow lakes through a slow-motion dance that can take centuries to complete. As rivers flow across flat terrain, they naturally develop curves that grow more pronounced over time. The faster flowing water on the outside of each curve erodes the bank, while slower water on the inside deposits sediment, gradually making the curves more extreme. Eventually, the river cuts through the narrow neck of land separating two parts of a meander, creating a shortcut that leaves the old curve isolated as a crescent-shaped lake. These oxbow lakes provide important habitat for waterfowl and other wildlife, creating pockets of still water in landscapes dominated by flowing rivers. Soil organisms create vast underground cities with populations that dwarf any human settlement. A single handful of healthy soil contains billions of bacteria, millions of fungi, and thousands of protozoa, along with numerous worms, insects, and other invertebrates. These soil communities break down organic matter, cycle nutrients, and create the pore spaces that allow plant roots to penetrate and water to infiltrate. The total biomass of soil organisms often exceeds that of all above-ground life combined. Yet these underground communities remain largely invisible to casual observation. Their activities literally support all terrestrial life by maintaining the biological processes that keep soil healthy and productive. Aurora displays follow 11-year cycles that correspond to peaks in solar activity. During solar maximum periods, increased solar wind activity creates more frequent and intense auroral displays that can be visible at lower latitudes than usual. The colors and patterns of auroras depend on which atmospheric gases are being excited by solar particles and at what altitude the interactions occur. Green auroras result from oxygen at lower altitudes, while red auroras indicate oxygen interactions higher in the atmosphere. Blue and purple hues come from nitrogen excitation. These celestial light shows often pulse and dance in rhythms that follow the magnetic field lines, channeling solar particles toward Earth's poles. Thermal springs host microscopic communities that represent some of Earth's most ancient life forms. These extremophile organisms thrive in temperatures that would kill most other life, using chemical energy sources that were abundant on early Earth. The colorful bacterial mats that surround many hot springs create rainbow patterns that change with temperature gradients, forming natural thermometers painted in living pigments. These heat-loving microbes may be similar to the first life forms that evolved on our planet billions of years ago, offering glimpses into biological processes that predate the evolution of photosynthesis and oxygen-breathing organisms. Seasonal bird migrations follow invisible magnetic highways that guide travelers across thousands of miles of featureless terrain. Many species have specialized cells containing magnetite crystals that function as biological compasses, allowing them to sense Earth's magnetic field lines. These magnetic maps are supplemented by celestial navigation, using sun angles and star patterns, creating redundant navigation systems that ensure successful journeys even under challenging conditions. Young birds learn migration routes by following experienced adults, creating cultural traditions of travel that are passed down through generations. Some migration routes have remained unchanged for thousands of years, connecting breeding and wintering grounds across vast geographic distances. Wetlands function as natural water treatment facilities, filtering pollutants and excess nutrients from runoff before it reaches rivers and lakes. The dense root systems of wetland plants slow water flow and provide surfaces where beneficial bacteria can break down harmful compounds. Cattails, rushes, and other wetland vegetation actively absorb nitrogen and phosphorus that would otherwise contribute to algae blooms in downstream waters. The complex hydrology of wetlands, with alternating periods of flooding and drying, creates diverse habitats that support numerous species while providing essential ecosystem services. Many urban areas are now using constructed wetlands to treat stormwater runoff and wastewater. Cave formations grow through processes so slow they can be used as geological calendars. Flowstone deposits, stalactites, and stalagmites form as mineral-rich water leaves behind microscopic layers of calcium carbonate, creating structures that record climate conditions over thousands of years. During wet periods, formations grow more rapidly, while dry periods leave thinner layers or growth rings. Scientists can analyze these cave deposits to reconstruct rainfall patterns from long before human weather records began. Some cave formations contain layers that correlate with known climate events like ice ages, volcanic winters, and medieval warm periods. Coastal dune systems migrate inland during storms and retreat during calm periods, creating dynamic landscapes that change with each season. Storm waves and high winds push sand farther inland, while gentle summer conditions allow vegetation to colonize and stabilize dune faces. Pioneer plants like beach grass and sea oats trap wind-blown sand with their stems and roots, gradually building new dunes that protect inland areas from storm surge. The height and position of coastal dunes reflect the long-term balance between storm frequency and vegetation establishment, creating natural barriers that adapt to changing conditions. Deep forest soils contain fungal networks that can extend for thousands of feet, connecting distant trees in cooperative partnerships. These mycorrhizal associations allow trees to share carbon, nitrogen, and other nutrients across the forest floor, with healthy individuals supporting neighbors that may be stressed by shade, drought, or disease. The fungal networks also transmit chemical signals that warn of insect attacks or pathogen infections, allowing trees to prepare their defenses before threats arrive. These underground communications create forest communities that function more like superorganisms than collections of competing individuals. Groundwater moves through underground aquifers at speeds measured in inches per year, creating vast reservoirs that took thousands of years to fill. The water emerging from many springs and wells fell as rain during very different climate periods, when regional vegetation and weather patterns were unlike those of today. Some deep aquifers contain water that is over 10,000 years old, providing a liquid connection to ancient climates. The slow movement of groundwater means that contamination can persist for decades or centuries, while depletion of these underground reservoirs may take equally long periods to naturally replenish. Hummingbird feeders create artificial nectar sources that can influence the migration timing and routes of these tiny aerial athletes. While supplemental feeding generally helps hummingbird populations, The timing of feeder maintenance can affect when birds begin their long-distance journeys. Early removal of feeders may prompt premature migration, while late-season feeding can delay departure until weather conditions become unsuitable for travel. The sugar concentration and cleanliness of artificial nectar sources can also impact hummingbird health and energy levels during the demanding hummingbird breeding season periods when they prepare for migration. Seasonal temperature changes in lakes create distinct layers of water with different densities, temperatures, and oxygen levels. During summer, warm surface water floats above cooler depths, preventing mixing and creating stratified conditions that can lead to oxygen depletion in deeper areas. Twice each year, in spring and fall, temperature equalization allows complete mixing that redistributes nutrients and oxygen throughout the water column. This seasonal turnover is essential for lake ecosystem health, bringing nutrients from the depths to surface waters where photosynthesis occurs, while carrying oxygen to deeper areas where fish and other organisms live. Ancient peat bogs preserve environmental records in layers of partially decomposed plant material that accumulated over thousands of years. These natural archives contain pollen grains, plant fragments, and other organic materials that reveal how vegetation communities changed over time in response to climate variations. Bog cores can be analyzed layer by layer to reconstruct past fire frequencies, drought periods, and even atmospheric pollution levels from different historical periods. Some peat deposits are over 20 feet deep, representing continuous environmental records that span the entire period since the last ice age. Wildfire creates a mosaic of different habitat types that supports greater biodiversity than uniform forest conditions. The varying intensities of fire create patches of complete clearing, mixed with areas of light burning that leave some trees standing and understory partially intact. This heterogeneous landscape provides nesting sites, foraging areas, and cover for different species with varying habitat requirements. Many plants and animals have evolved specific adaptations to post-fire conditions, timing their reproduction to coincide with the increased resources and reduced competition that follow natural fires. The nutrients released from burned vegetation create fertile conditions that support rapid plant growth and high wildlife populations. Underground streams follow gravity and geological structure, creating hidden watersheds that may drain in completely different directions than surface water flow. Limestone regions often have extensive cave systems where underground rivers flow for miles beneath the surface, sometimes emerging as large springs in distant valleys. The paths followed by groundwater can cross surface watershed boundaries, creating underground connections between apparently separate drainage basins. Dye tracing studies have revealed underground streams that travel over 20 miles through cave systems before emerging at springs that seem unrelated to their distant sources. Lichen partnerships demonstrate remarkable longevity, with some individuals persisting for thousands of years in harsh environments where other organisms cannot survive. These composite organisms grow incredibly slowly, sometimes less than a millimeter per year, but their dual nature allows them to colonize bare rock surfaces and survive extreme temperature variations. Arctic lichens may experience temperatures ranging from 60 below zero to over 100 degrees Fahrenheit, while desert species endure months without any moisture. Their ability to shut down all metabolic activity during adverse conditions allows them to wait out unfavorable periods that would kill most other life forms. Seasonal migrations of nutrients through forest ecosystems follow predictable patterns that support different organisms at different times of year. Spring leaf emergence draws stored nutrients up from roots into new foliage, while autumn leaf fall returns these nutrients to the soil surface. The timing of nutrient pulses influences everything from soil microbial activity to the breeding cycles of forest birds and mammals. Decomposing leaves provide different nutrients at different rates, with some compounds becoming available within weeks, while others remain locked in organic matter for years before being released by slow decomposition processes. Crystalline formations in caves grow according to the same mathematical principles that govern snowflake formation and mineral growth throughout nature. The hexagonal patterns seen in many cave crystals reflect the underlying atomic structure of the minerals, while the branching patterns of flowstone formations follow fractal geometries that appear at many scales in natural systems. Temperature, humidity, and the chemical composition of seeping water all influence crystal growth rates and final forms, creating formations that serve as three-dimensional records of past cave conditions. Some cave crystals continue growing for thousands of years, adding microscopic layers that preserve detailed environmental histories. Pollinator gardens create stepping stone habitats that support migrating butterflies, bees, and other insects across landscapes fragmented by human development. Native plants that bloom in sequence throughout the growing season provide continuous nectar sources, while diverse flower shapes and sizes accommodate different pollinator species with varying feeding requirements. The proximity of suitable nesting sites and overwintering habitat enhances the value of flower gardens for supporting resident pollinator populations. Even small urban gardens can contribute significantly to pollinator conservation when they provide appropriate plant species during critical periods of the annual cycle. Soil formation processes transform solid bedrock into the living medium that supports terrestrial ecosystems through the combined action of weather, chemistry, and biology over geological timescales. Physical weathering cracks rock surfaces, while chemical weathering dissolves minerals and creates clay particles. Pioneer organisms like lichens and mosses begin the process of adding organic matter, while roots and burrowing animals create structure and pore spaces. The development of distinct soil layers reflects thousands of years of these integrated processes, with different soil types forming under different climate and vegetation conditions. Deep prairie soils represent some of the most biologically active and carbon-rich soils on Earth, built through millennia of grassland growth and decay. Mountain snowpack acts as a natural reservoir, storing winter precipitation and releasing it gradually throughout the growing season. Each snowflake that falls in high elevation areas becomes part of a vast frozen bank account, accumulating layer by layer until spring temperatures begin the slow process of withdrawal. The timing of snowmelt is precisely calibrated to the needs of downstream ecosystems, with the gradual release providing steady water flow during the driest months of summer. Snow depth measurements and temperature records allow scientists to predict water availability months in advance, making snowpack one of nature's most reliable forecasting systems. The albedo effect of snow-covered mountains also influences regional climate by reflecting sunlight back to space, keeping surrounding areas cooler than they would be with bare ground. River meanders follow mathematical curves that appear throughout the natural world, from the spiral of galaxies to the coiling of DNA. The ratio between a river's actual length and the straight-line distance between 2 points tends toward a constant value regardless of the river's size, creating patterns that repeat at every scale. This meandering behavior emerges naturally from the physics of flowing water, with faster currents on the outside of curves eroding banks, while slower water on the inside deposits sediment. Over time, these small differences accumulate into the graceful S-curves that characterize mature river systems. The wavelength of meanders correlates with river width and flow volume, creating predictable relationships that engineers use to design stable channel modification, NS. Moss gardens create miniature ecosystems that support communities of microscopic animals living in films of water thinner than human hair. These tiny water bears, rotifers, and nematodes navigate between moss leaves like explorers in a green jungle, feeding on bacteria and organic particles trapped in the moist spaces. During dry periods, many of these microscopic residents enter cryptobiosis, essentially pausing their life processes until moisture returns. A single cushion of moss may contain thousands of these invisible inhabitants, creating complex food webs in spaces measured in millimeters. The water-holding capacity of moss allows these communities to persist through drought conditions that would eliminate similar organisms in less protected environments. Thermal layering in lakes creates distinct zones where different fish species thrive at their preferred temperatures and oxygen levels. Cold water fish like trout remain in the deeper, cooler layers during summer, while warm water species concentrate near the surface where temperatures suit their metabolism. The boundary between these layers, called the thermocline, acts like an invisible ceiling that prevents mixing between surface and deep waters. This stratification concentrates nutrients in different zones, creating vertical habitats as distinct as different forest layers. Fish and other aquatic organisms often migrate vertically through these layers on daily cycles, following food sources and optimal conditions. Desert washes transform from dry, sandy channels into rushing rivers within minutes of distant rainfall, carrying flash floods that reshape entire landscapes in a single storm event. These ephemeral waterways remain dormant for months or years between flow events. Yet they support specialized plant communities adapted to extreme fluctuations in water availability. Seeds buried in wash sediments can remain viable for decades, germinating only when sufficient water triggers mass blooming events that paint desert valleys in temporary carpets of wildflowers. The timing and intensity of these flash floods influence soil deposition patterns, creating fertile strips through otherwise arid terrain. Fungal spore dispersal follows wind patterns that can carry reproductive cells across entire continents, creating genetic connections between forests separated by thousands of miles. The release timing of spores is often synchronized with weather conditions that maximize dispersal distance, with many species releasing their microscopic offspring during specific atmospheric conditions. Some fungal spores can remain viable in the atmosphere for weeks, traveling through high-altitude air currents that carry them far beyond their parent organisms. This long-distance dispersal explains why many mushroom species appear suddenly in suitable habitats, far from previously known populations. Tidal pool communities demonstrate remarkable resilience to extreme environmental fluctuations, with organisms surviving conditions that change dramatically twice each day. During low tide, these marine creatures must endure direct sunlight, temperature extremes, and desiccation, while high tide brings crashing waves and potential predators from deeper waters. Many tidal pool inhabitants have evolved sophisticated behavioral and physiological adaptations that allow them to thrive in this challenging interface between land and sea. Sea anemones close their tentacles and retain water in their body cavities, while barnacles seal their shells and wait motionlessly for the tide's return. The vertical zonation of different species reflects their varying tolerance for exposure, creating distinct bands of life that correspond to different tidal heights. Forest canopies create multiple layers of habitat that function like vertical neighborhoods, each supporting different communities of plants and animals. The emergent layer receives full sunlight and experiences the greatest temperature extremes, while the understory remains cool and humid with filtered light. Epiphytes growing on tree branches create aerial gardens that support insects, amphibians, and even small mammals that may never descend to the forest floor. The complex three-dimensional structure of mature forests provides countless microhabitats, from hollow tree trunks to moss-covered branches, each occupied by specialized organisms adapted to specific conditions. Groundwater discharge through springs maintains stream flow during drought periods, providing crucial habitat for aquatic organisms when surface water sources disappear. These groundwater contributions often have different temperatures and chemical compositions than surface water, creating unique mixing zones where specialized communities develop. Cold water springs in warm climates provide thermal refugia for fish and other organisms during extreme temperature events, while mineral-rich springs support endemic species found nowhere else. The consistent flow and stable temperatures of spring-fed streams make them particularly valuable for maintaining aquatic biodiversity during climate extremes. Seed banks buried in soil represent biological savings accounts that can remain dormant for decades until environmental conditions trigger mass germination events. Prairie fires, flood cycles, and seasonal temperature patterns all serve as withdrawal signals that activate different portions of these soil-stored seed communities. Some seeds require specific scarification or chemical treatments that only occur during certain disturbance events, ensuring that germination coincides with favorable growing conditions. The diversity and abundance of buried seeds often far exceeds the visible plant community, representing the potential for ecosystem renewal following major disturbances. Butterfly migration routes span multiple generations, with individual insects completing only portions of journeys that may cover thousands of miles. Monarchs beginning the southward journey in Canada will never see the wintering grounds in Mexico, yet their great-grandchildren will somehow find the exact same trees used by their ancestors. The navigation mechanisms that enable these multi-generational migrations involve combinations of genetic programming, solar compass orientation, and possibly magnetic field detection. Each generation carries forward both the instinctive knowledge and the physical capacity needed for their portion of the epic journey. Wetland water levels fluctuate in cycles that trigger different reproductive strategies among resident wildlife populations. Many waterfowl time their nesting to coincide with optimal water depths for their preferred food sources, while amphibians may delay breeding until pond levels ensure tadpole survival. The plant communities in seasonal wetlands have evolved seed germination patterns that respond to specific water level cues, creating predictable succession patterns as waters rise and fall. These hydrological cycles, whether natural or managed, are essential for maintaining the biological diversity that makes wetlands among the most productive ecosystems on Earth. Pollination networks connect flowering plants across landscapes through the movement patterns of their mobile pollinators, creating invisible webs of genetic exchange that maintain plant population health. Individual bees, butterflies, and other pollinators may visit hundreds of flowers during single foraging trips, inadvertently carrying genetic material between plants that may be separated by miles. The timing of flower blooms and pollinator activity creates temporal networks that shift throughout the growing season, with different species partnerships becoming active at different times. These pollination networks are particularly important for maintaining rare plant populations that depend on cross-pollination for reproductive success. Underground fungal networks facilitate nutrient exchange between different plant species, creating cooperative relationships that blur the boundaries between competition and collaboration. Trees growing in nutrient-poor soils may receive essential minerals from fungal partners connected to plants growing in richer areas, while providing carbon in return through their photosynthetic activities. These mycorrhizal partnerships can persist for decades, creating stable underground economies where resources are traded according to supply and demand. The complexity of these fungal networks rivals that of human transportation systems, with multiple pathways and redundant connections, ensuring continued function even when portions of the network are damaged. Seasonal light cycles trigger hormonal changes in wildlife that regulate everything from migration timing to reproductive readiness, creating biological calendars more precise than any human timekeeping system. The gradual lengthening of days in spring initiates complex physiological preparations for breeding season, while shortening autumn days trigger fat accumulation and other winter survival adaptations. These photoperiodic responses are so finely tuned that many species can detect day-length changes of just a few minutes, allowing them to anticipate seasonal transitions weeks or months in advance. Even small shifts in seasonal timing due to climate change can disrupt these carefully calibrated biological rhythms. Cave ecosystems demonstrate how life adapts to environments completely isolated from solar energy, developing unique food webs based entirely on organic matter that drifts or washes in from surface environments. Specialized cave fauna have evolved enhanced sensory abilities to compensate for the absence of light, with many species developing elongated appendages and heightened chemical sensitivity. The constant temperatures and humidity levels in deep caves create stable environments where evolutionary changes occur slowly, preserving ancient lineages that have remained virtually unchanged for millions of years. These underground communities represent some of the most specialized and vulnerable ecosystems on Earth. Wildfire smoke particles serve as condensation nuclei for cloud formation, influencing precipitation patterns across vast areas downwind of burn sites. The microscopic particles released during fires provide surfaces where water vapor can condense, potentially increasing rainfall in areas that might otherwise remain dry. Large fires can create their own weather systems, generating winds and even lightning that can spark additional fires. The smoke plumes from major wildfires can be tracked by satellite as they circle the globe, affecting air quality and weather patterns thousands of miles from the original burn site. Seasonal bird song patterns follow predictable cycles that correspond to territorial establishment, mate attraction, and breeding activities throughout the year. Dawn choruses reach peak intensity during spring migration periods, when newly arrived birds establish territories and seek mates, while song activity diminishes during molting periods, when energy is directed toward feather replacement. Young birds learn songs by listening to adults, creating regional dialects that can persist for generations within local populations. Changes in singing behavior often provide early indicators of environmental stress or habitat degradation. Natural springs emerge where underground water pressure forces groundwater to the surface, creating oases that support diverse communities in otherwise dry landscapes. The temperature, mineral content, and flow rate of springs reflect the depth and geological formations through which the water has traveled during its underground journey. Some springs maintain constant temperatures year-round, providing thermal refugia for aquatic organisms during seasonal temperature extremes. The unique chemistry of individual springs often supports endemic species that have evolved specifically to exploit these specialized aquatic environments. And so our gentle journey through Earth's quietest secrets comes to a close. We've wandered together through underground rivers and singing sands, through the patient conversations of ancient trees and the soft glow of creatures in the deepest seas. Each fact a whisper, each discovery a lullaby from the world that holds us. May these peaceful marvels settle into your dreams like dewdrops on morning grass. And may you wake with wonder for the extraordinary planet spinning quietly beneath your feet. Sweet dreams.